Welcome to the channel Untold Theory. In this video, we will tell you about the most important constants of physics. What are these constants and why do they get those values?
Do you know that the constants of physics are a mystery? Nobody knows why these constants get these values. The constants are known, but why they get these values is totally a mystery. So what are the constants of physics and astronomy and what are their meanings? Let's have a look at some most famous constants. The cosmological constant. In cosmology, the cosmological constant, which is usually denoted by the letter lambda, is the energy density of space, or vacuum energy, that arises in Albert Einstein's field equations of general relativity. It is closely associated to the concepts of dark energy. Einstein originally introduced the concept in 1917 to counterbalance the effects of gravity and achieve a static universe, a notion which was the accepted view at the time. Einstein abandoned the concept in 1931. Interestingly, he discovered it but then abandoned it. A constant which is still accepted by physics of today. Until the late 1990s, most physicists assumed the cosmological constant to be equal to zero. That changed with the surprising discovery in 1998 that the expansion of the universe is accelerating. Today it is accepted that the constant is greater than zero. The cosmological constant lambda is the simplest possible explanation for dark energy, and is used in the current standard model of cosmology. Another constant is the elementary charge. Have you ever reached out to touch a metal doorknob when a spark suddenly jumped between your hand and the doorknob, giving you a little shock? Or maybe you've brushed your hair on a cold, dry day and, afterwards, saw that your hair was standing up? What's going on to cause these things to happen? It's all due to a phenomenon called static electricity. However, determining exactly what particles are carrying this charge and how much charge these individual particles have is much more complex. The smallest amount of charge that can exist, the elementary charge, usually denoted by E or sometimes C, is the electric charge carried by a single proton or, equivalently, the magnitude of the negative electric charge carried by a single electron. It is also unknown why its value is exactly this. The speed of light in vacuum, commonly denoted c, is a universal physical constant important in many areas of physics. According to special relativity, c is the upper limit for the speed at which conventional matter and information can travel. Though this speed is most commonly associated with light, it is also the speed at which all massless particles and field perturbations travel in vacuum, including electromagnetic radiation and gravitational waves. Particles with non-zero rest mass can approach c, but can never actually reach it. The speed at which light propagates through transparent materials, such as glass or air, is less than c. Similarly, the speed of electromagnetic waves in wire cables is slower than c. Light in glass travels at approximately 2000 kilometers per second. The speed of light in air is about 90 kilometers per second slower than c. In 1905, Albert Einstein postulated that the speed of light c with respect to any inertial frame is a constant and is independent of the motion of the light source. The Planck's constant. It is the quantum of electromagnetic action that relates a photon's energy to its frequency. The Planck constant multiplied by a photon's frequency is equal to a photon's energy. The Planck constant is a fundamental physical constant denoted as, and of fundamental importance in quantum mechanics. The end of the 19th century, accurate measurements of the spectrum of black-body radiation existed, but predictions of the frequency distribution of the radiation by then existing theories diverged significantly at higher frequencies. In 1900, Max Planck empirically derived a formula for the observed spectrum. He assumed a hypothetical electrically charged oscillator in a cavity that contained black body radiation could only change its energy in a minimal increment that was proportional to the frequency of its associated electromagnetic wave. He was able to calculate the proportionality constant from the experimental measurements, and that constant is named in his honor. In physics, the other interesting constant is the fine structure constant, also known as Sommerfeld's constant, commonly denoted by alpha. The Greek letter alpha is a fundamental physical constant characterizing the strength of the electromagnetic interaction between elementary charged particles. It is a dimensionless quantity related to the elementary charge E, which characterizes the strength of the coupling of an elementary charged particle with the electromagnetic field. As a dimensionless quantity, its numerical value, approximately 1/137th. The fine structure constant is the possibility of an electron to release a photon. What about the gravitational? The gravitational constant, also known as the universal gravitational constant, the Newtonian constant of gravitation, or the Cavendish gravitational constant, denoted by the letter G, is an empirical physical constant involved in the calculation of gravitational effects in Sir Isaac Newton's law of universal gravitation and in Albert Einstein's general theory of relativity. The gravitational constant is a physical constant that is difficult to measure with high accuracy. This is because the gravitational force is an extremely weak force as compared to other fundamental forces. There are many other constants in physics. We mentioned here some of the interesting constants. So the conclusion is that the existence of life in Earth is not just related to its special position in its orbit in the solar system. It is also related to the very sensitive rules of our homogenic universe. If these constants were just a little more different than their current values, the chain of evolution may not have started. Even the Big Bang occurred. The atoms would not have had suitable conditions to create the first atoms. Maybe, universe would only full of some energetic particles. So one may think that these constants are chosen specially by a god, but today physicists do not think so. According to many of them, and latest theories of physics, there may be infinitely many universes with infinitely many physics rules where these constants may have very different values, and our universe may be just one of them. So this explains how our universe was born with these special rules. It is just one of those infinitely universes what can have also infinitely many copies. And of course this is a theory, but it is highly accepted today. Thank you for watching our video. Please do not forget to subscribe if you liked our video.